What we want to do is we want to use these rules that we've been given here to allow us to multiply these binomials easier than using the FOIL method. And given certain expressions, we can do that. So instead of using the FOIL method, which is what we used during last class, we'll be able to use these special rules. Again, given that the binomials fall into one of these three categories. So the first one, if you have an expression a minus b times a plus b, when you multiply those together, it's actually just equal to a squared minus b squared. Our second one, if you have the expression a plus b, and that expression is raised to the second power. Again, remember when you're raising something to the second power, what that means is you're taking that value and multiplying it by itself. So if we're taking a binomial a plus b and raising it to the second power, what that means is we take a plus b and multiply it by itself. So we take a plus b times a plus b. And what that's going to give us is the expression a squared plus 2ab plus b squared. And then finally, if we have a minus b squared, that's going to be a minus b times a minus b, and that's just going to be equal to a squared minus 2ab plus b squared. Now again, we could verify that these all work using the FOIL method. So if you just FOILed these out, you would see that we get each of these results. But since these occur very frequently, we want to use these rules to sort of make the process a little bit quicker. So we have 3 examples that we want to do, and we're going to see which case we fall into, and then use the appropriate rule. So our first one, we have x minus 2 times x plus 2. Now that's going to fall under our first category. So what we want to do is identify what is our a and what is our b. So in this case, our x is going to be our a value, and our 2, see how we're adding and subtracting 2? That's going to be our b value. And so what we're going to do is we're going to plug these values in and see what we get. So this rule tells us that this expression is equal to a squared minus b squared. So this should be equal to, our a is x in this case. So this is x to the second power, x squared. Okay, we have x squared. And now it's minus b squared. Now our b is 2 in this case. So this is minus 2 squared. And now we can simplify this just because we know that 2 squared is just equal to 2 times 2, which is 4. Okay? For the second one, we have x plus 3 squared. So that's going to fall into our second category. So again, what we want to do is identify what is our a and what is our b, and then plug them in appropriately. So in this case, again, our x is going to be our a value, and our 3 is going to be our b value. And so we want to remember that x plus 3 squared, this should be equal to, according to the formula, x plus 3 times x plus 3. And then using the rule that we're given, this is equal to, now our x is acting as a, so this is x squared plus 2 times a times b, so this is times x, and then times our b is 3, plus, and then it's b squared, so our b is 3 in this case, so this is 3 squared. Now I'm going to simplify this a little bit. When you have a bunch of terms multiplying each other, you can use the commutative property, which, if you remember, says that you can multiply in any order. So I'm going to take the 3 and multiply it by the 2. And I'm also going to simplify this 3 squared over there. And so we have is x squared plus 2 times 3 is 6 times x. Again, you don't want to forget the x, make sure you carry it down. And then finally, 3 squared is just equal to 3 times 3, which is 9. Okay. And now for our last rule, or our last example, I should say, we have x minus 3 squared, so that's going to fall under our last rule. So again, we have our a's over here, and our b's over here. So again, we just want to make sure we're plugging everything in appropriately. So in this case, our 3 is our b value, and x is acting as our a value again. And so we get, if you remember, this is going to be x minus 3 times x minus 3. And this is equal to, let me just put a little divider here. So this is going to be equal to a squared. Now our a is x. So this is x squared minus 2 times a times b. So again, times x, and then times 3. And then we have plus b squared, and our b is 3. So I want to do the same thing I did before, where I take this 3 and multiply it by the 2, and simplify 3 squared as well. So this is going to be x squared minus 6x plus 9. And that's it. So again, you just want to make sure that you identify what is your a and what is your b, and then instead of using the FOIL method, you can use one of these special rules if they do apply.